Hello everyone. So in this video I'm going to explain the concept of electromotive force EMF, internal resistance and potential difference. So we look at the first one, which is electromotive force or EMF. So by definition, EMF is the energy provided by the source, which is the battery or the cell, to each unit charge that flows from the source. Internal resistance, or we denote as a small letter of R, is the resistance of the chemicals inside the cell, which is the battery, between the poles. Okay, let's say we have a resistor here, and we have a battery connected to a battery of 6 volt. And then we connect this battery, in between this battery, to a voltmeter. Okay, so what this voltmeter will do is this voltmeter will measure the potential difference across the battery. So voltmeter ni akan measure the value of potential difference or terminal voltage. Okay, so we have a 6 volt battery kan, but then apabila kita connect dengan voltmeter, this voltmeter will show a reading of 5.8 volt. Okay, kenapa benda ni boleh berlaku? Sedangkan kita ada bateri 6 volt. So, bagaimana sudah value 0.2 volt ni pergi mana pula? Okay, so this one actually happen because in the battery, we have what we call as internal resistance. Kita ada resistance dekat dalam battery ni. Okay, so dia kita tulis dia sebagai small letter of R. Okay, so what happened here is before the battery can supply the voltage to the rest of the circuit, okay, before they supply voltage to the rest of the circuit, there is a potential drop here. Disebabkan kita ada resistance kan. Kalau ada resistance, meaning that there is a potential drop. So we have a potential drop here. Potential drop. So this potential drop is actually the value of 0.2 volts. So ada 6 voltage dekat sini and then ada 6 volt dekat sini and then disebabkan ada resistance, so sudah hilanglah 0.2 volt ni is lost in the battery before it is supplied to the rest of the circuit. So meaning that here, okay, we have a total voltage available. Total voltage available ni adalah value from the battery, which is the value of EMF. So total voltage available will be equal to voltage loss in the circuit, ataupun nama lain dia adalah potential difference ataupun terminal voltage. Maksudnya ni adalah value yang voltmeter tu measure ni. Okay, voltmeter dekat sini actually measure the value of potential difference or terminal voltage, and then plus with the voltage loss in the battery. So voltage loss in the battery is due to the internal resistance, which is equal to current times with the internal resistance. Okay, ataupun lebih senang kita akan tulis sebagai EMF sama dengan VR, which is potential difference, plus VB ataupun voltage loss in the battery. Okay, so maksudnya 6 volt tadi tu adalah value daripada EMF. Okay, so 6 volt adalah value daripada EMF, and then 0.2 tu adalah value that is lost in the battery, and then this one is 5.8 volt. Okay, so maksudnya dekat sini 5.8 tambah dengan 0.2 barulah kita dapat value sebenar daripada battery. Okay, since this one is a series circuit, right? So meaning that the current will be the same throughout the circuit, which is why current dia akan sama lah. So we can factorize. So EMF, which is equal to I times with the resistance plus the internal resistance. So depends on the circuit. If we have another resistor, kalau kita ada another resistor here that is connected in series, so tambah lagi lah, tambah another resistance. Okay, so boleh faham dekat sini, we either use this formula here or there's another formula. Kalau kamu tengok dekat kamu punya nota, if we rearrange, okay, so actually we have this one, right? Plus IR, or untuk kita dapatkan value of V tu, which is the potential difference, okay, E minus I small resistance, which is internal resistance. So depending on the information that we have, based on the equation, kita tengoklah mana satu formula yang kita guna. This one, or this one. Okay. Okay, next we look at the internal resistance. Okay, internal resistance, there are a few factors that influence this internal resistance. First one is the distance between electrolyte, which is directly proportional. So distance increase, meaning that the internal resistance will increase. So distance increase, internal resistance will increase since it is directly proportional. Next one is the surface area of the electrode in electrolyte, which is inversely proportional. So area increase, the internal resistance will decrease. Number 3, temperature of electrolyte, which is inversely proportional. So temperature increase, internal resistance will decrease. Concentration of electrolyte also inversely proportional. So concentration increase, internal resistance will decrease. So this one sudah menjawab example number 10. Which is example number 10 dekat sini dia tanya, how does the internal resistance of an electrolytic cell depend on concentration and temperature? So explain your answer. Okay, kita tengok, because we want to know what happened to the internal resistance if we increase or decrease the temperature and the concentration. Okay, first one, the concentration. So since concentration ni adalah inversely proportional, right? Tengok dekat sini semula. Inversely proportional. So meaning that if we increase the concentration, the internal resistance will decrease. So vice versa juga, if we decrease the concentration, internal resistance will increase. And then next one, the temperature. So temperature is, okay, temperature ni ada sama juga inversely proportional to the internal resistance. So temperature increase, internal resistance will decrease. So this one, okay, you just write down in terms of words. Jangan tulis anak panah macam ni lah. So this one is just for you to show, for me to show it to you clearly. Okay, the relationship between these two. Okay, so example 11 until 13 I will discuss in the next video. So that is all for subtopic 3.4. Okay, thank you.